Hi guys, I want to tell you a little bit about the kind of radical changes that we've seen in this field of quantum information and quantum technologies. And I'm not such an old guy, but it's really been a pretty remarkable difference in the perception of how people view this field. So I want to tell you a little bit of that story. So let me go back to sort of the 90s. So when I was a PhD student in Australia, what you do is you do like an honors project where you do some research. And what you do is you generally kind of choose from like a little booklet what kind of projects to do. So just as a bit of an aside, some of you might think, why can't you just think up your own project? Isn't it a bit lame to sort of choose it from some booklet? It should be your own work. Well, the sad fact is that actually, after learning 3 years of undergraduate physics, you actually have not really a very good idea of what is happening in the current stage of physics. Generally, what you learn up until the third year of physics is, things like maybe quantum physics and relativity, but all these theories are about 100 years old. So essentially, it takes you, university physics takes you from some kind of physics which is about, say 400 years old to one which is, at least about 100 years old. So, with 100 years outdated knowledge, you really still can't actually come up with your own research topics, unfortunately. So this is a kind of sort of a fact of physics. So it's an incredibly deep field, and it takes a long time to learn. So so I chose a kind of topic which was related to the foundations of quantum mechanics, and I chose a particular topic, and I had a supervisor who goes and shows me this particular article and tells me to go and read it. So this article is called Is the Moon There When Nobody Looks? Reality and the Quantum Theory. So this is a famous kind of popular science rendition of the types of experiments that people are starting to do in these days. This is published in 1985, and essentially it talks about the experiments to verify the Bell inequality. So John Bell proposed this idea that you can actually test whether quantum mechanics has a realist type of interpretation, and found that there's an inherently non-local aspect to it. You can check out my lectures on this topic for more detail. So I go and read this article, and it's really a fantastic article. I love this article. It's it's just so I just love the pictures. I just love the whole concept, this whole philosophical aspect. And due to some unfortunate circumstances, I couldn't continue working with this particular supervisor, even though I loved this topic, right? So I asked some of the other professors around my university, can I kind of continue in this topic, because I really like this topic. And everybody sort of said that, this foundation of quantum mechanics stuff it's really not, it doesn't really lead anywhere. It's not even proper science. That was the kind of connotation that they were sort of making. So, so basically, I had to sort of change projects, and so I did an entire PhD on different topics which were sort of unrelated to this foundation stuff. I did some things in condensed matter physics, atomic physics, particle physics, and then after I finished my PhD, I sort of sat and went, yeah, well, I learned a lot, but was that really what I wanted to do, actually? And then I started to think again about computers, quantum information, and eventually I started doing a postdoc in Japan, again on basically this topic. So it took me sort of 4 years to get around and start this topic, which is more related to quantum information. And so quantum information is an interesting field because it's not only about people that do quantum computers and other things like that, technological related. A lot of people are also interested in this foundational stuff because it really relates intimately with how you can view quantum states as sort of information. And so, Bell's inequality can be viewed really in a sort of an informational sense. So there's a kind of a lot of overlap with that. So I do this whole, I do the postdoc in quantum information, and so this is now where I'm at. Now I'm a professor at NYU Shanghai, but the field has really changed kind of radically in this time. So from the time in the sort of the 90s of when I was a student, when it was rather frowned upon and people thought, oh, this foundation stuff is it's not real science, it's sort of metaphysics, it's philosophy, and now it's really radically changed so that people, it's a bona fide kind of subfield of physics. This field of physics didn't really exist actually in the 90s. Now it's really quite a major subfield of physics, along with other fields like condensed matter physics. So it's really kind of recognized as a kind of a regular mainstream topic that you can do, and now we're really at the stage where it's kind of booming. And I think that one of the turning points. So you might ask many people where this particular turning point came. So for me, it was this article that was around about the point where things really started to turn around. I think this was published in around 2015 or 14, where it was reported that superconducting qubits were at the threshold for fault tolerance. So basically what this means is that error correction should, at least in principle, work, because now the gates and the qubits were really good enough such that error correction can work. And the way error correction works, or quantum error correction works, is that once you are like below a particular error rate, then the more error correction that you do, the better the overall error performance of the device is. But if your errors are too large, then actually your logical errors are getting even worse by doing the error correction. So you're better off not doing at all. So kind of it's a point where once you go below, then you can actually kind of start to gain. And so I think this was around the time when people went, oh, wait a minute, quantum computers, we can totally make it now. So, before around about this time, people were going, no, quantum computers, they're 30 years away, we'll never make it. And then, it'd be like the story of sustainable fusion, where people always say, it's like, 30 years away. And then, you come back 20 years later and they still say it's 30 years away. So it's a goal that keeps on getting further away. But this was a point where, people think, okay, well, now it's done. And then, it's very funny that people sort of start to say, oh, yeah, I always knew that this could be done. I was always saying that when, 3 years ago, everybody was saying it couldn't be done. So, people's perception changes really just like that, right? And another sort of notable mention are all the kind of big quantum communication experiments that were really done here in China. And around about 2017, the Chinese groups launched a satellite and demonstrated that you can do really long distance entanglement through satellite. And so this was really quite kind of big news in the community at the time. So sort of another notable mention. So we're at this stage now that there are many commercial companies, IBM, Google, they're all making quantum computers. Everybody's saying it's going to be the next kind of emerging technology in terms of information. And when you start seeing articles in investment kind of journals and newspapers, when these are a couple of articles from NASDAQ, how to invest in quantum computing, which are the leading companies, and this is another article from late last year saying, forget Bitcoin, forget Tesla, it's all about quantum computing now. You do start to wonder whether now it's been hyped kind of too much, but it's kind of a remarkable transformation from only maybe about 20 years ago, when people didn't even believe it was science, to now everybody thinking, how and where do I invest in? So a little bit of a little anecdote from myself. I'm sure many people have similar stories. But if you're interested in quantum computing and you want to learn more about it, then there's a lot more on this channel that you can see. So, of course, like and subscribe. Okay, see you later. Bye.